So let me give you another example. So in this video, we're going to try to determine if this series will converge or if it will diverge. Remember, in the previous video, we established that the square root of n will be much bigger than the natural log of n as n tends to infinity. We've already established this. Okay, so bear this in mind. So now we are trying to determine if this will converge or if this will diverge. So when n heads towards infinity, which term will dominate? So here you've got this thing, this block plus this block plus this block, and well, the numerator, which you see this term here will be much bigger than the natural log or this irrelevant negligible number 2. So as n gets bigger and bigger, the numerator will just be the square root of n. As n gets bigger and bigger, here you're adding a negligible amount here, so it's just going to act as n squared. And then if you tidy this up, so you can imagine this as being n to the power of half, and then n2 divide top and bottom by n to the power of half. Well, that would then give you 1 over n to the power of 3 over 2. So we are going to compare this series with this series. We know nothing about this series. We don't know if it's going to converge or if it's going to diverge. But we do know that this is going to converge by the p series. Well, this p here, this p here is bigger than 1, so it's going to converge. So this thing here we know is going to converge. So let's start again. We know nothing about this, so we are going to compare it with 1 over n to the power of 3 over 2, because this thing here is bigger than 1. This whole series here will converge. We don't know anything about this yet. So hang on. So we are going to compare this with this. Okay. So now let's look at this. So now always check this first part here. So an will always be bigger than 0. This thing here will always be bigger than 0. So now let this here be an, let this here be bn. So now let's get an divided by bn. And see what the limit is. If the limit is a constant bigger than 0, then we will need to take this scenario. If the limit an divided by bn equals 0, then we need to consider case 2. If this divided by this, equals infinity, then we need to consider case 3. So now let's determine the limit of an divided by b of an divided by b of an divided by bn. So now here you've got one thing divided by another thing. That's the same as you getting that thing multiply with the reciprocal of this. So that will then give you this. So now it's top times top. So this times this. That will then give you this. So n to the power of half. That's the square root, times n to the power of 3 over 2. So you add these two, that will then give you this 4 over 2, which is 2. And then this times this, that will then give you this thing times this thing, and then this times this, that will then give you this, and then 1 times this, that will then give you this. So now you ultimately want to know what this whole thing here will be as n gets very big. As n gets very big, let's look at the numerator. Let's look at this here. Here you've got 3 blocks. 1, 2, 3. Which block will dominate as n gets very big? So here you've got let's compare this with this. n squared versus n over 2. Even if you have, let's say, 98 here, eventually x squared will be bigger than this, because this is really 1.5 here, n to the power of 1.5. But eventually n squared will be much bigger than this. Even if you have 998 n to the power of 3 over 2, n squared will eventually overtake this thing here as n tends to infinity. So this versus this, this is just going to dominate as n tends to infinity. So we can pretty much ignore this. So now you've got this block versus this block. Which block will dominate as n gets bigger and bigger and bigger? So remember, in the previous video, we've established that the square root of n, which is n to the power of a half, is much bigger than natural log of n. So if the square root of n is much bigger than the natural log, let's just imagine this as being square root of n, so n to the power of a half. So this times this will give you n squared, so which is the same as this. So in the previous video, we've established that n to the power of a half will be much bigger than the natural log of n. So this here, natural log of n, will be much less than this. So the point is that the best case scenario, which is n being n to the power of half, will be the same. So the combination of the two here will be the same as this. So therefore, this must be much bigger than this. So as n tends to infinity, this is going to be the dominant term. Because if you think about it, natural log here, the best case scenario is when n is a half, and then the best case scenario is when this equals this thing here. So you know that this will be much bigger than this. So anyway, as n tends to infinity, looking at the numerator, this term will dominate, meaning that as n gets bigger and bigger and bigger, this thing here is going to be negligible in comparison to n squared. This thing is going to be negligible in comparison to n squared. So you can consider this whole thing here as being n squared. And then as n gets, looking at the denominator, as n gets bigger and bigger, you're adding on an insignificant amount here. So as n gets bigger and bigger, it was just going to act as n squared. So the limit will be 1. So the limit of this whole thing here, the limit of an over bn is 1. So the limit of this, the limit is 1. So looking at this, so when we get an divided by bn, it gave us a limit of 1. So we should consider case 1 here. It gave us a limit of 1, and 1 is bigger than 0. So we've got to consider this case here. So now what the theorem is saying is that, because this has been satisfied, the theorem says that if bn converge, then this will converge. If bn diverge, then this will diverge. But then looking at this here, our bn here converge. Our bn here will converge. Therefore, the series that we know nothing about, it actually converge. So this series here will actually converge. Okay.